Good morning, chemistry students. Welcome to class again today. I want to believe that you enjoyed your break, and I also look at your scores for C2, and I was very impressed with what you did. Your performances were very encouraging. Majority of you scored above 20, which was very encouraging. That shows you've been following the class all along, and you've been taking the evaluation questions I've been sending to you. So that's good. So moving on to today's work. Uh, Before I go to today's work, I quickly want to recap what we did for week 7 and week 8. So for week 7, I remember we concluded our topic on carbon and its compound, and we did carbon 2 oxide, the laboratory preparation, and the properties of carbon 2 oxide. So that's what we did for week 7. So let's move to week 8. Week 8. So for week 8, Uh, I've not explained this week 8 because of the salary break. The day we are supposed to have the class, there was break, there was salary break, so we could not explain it. But I remember I sent the notes to you, so let's start with that. Then, if time permits, we are going to look at week 9 as well. So for week 8, the topic is hydrocarbon and its main classes. Hydrocarbons or hydrocarbon and its main classes. So when you talk about hydrocarbon, what do we mean? Hydrocarbon is a compound consisting mainly of two elements, and that is hydrogen and carbon. Those two elements are the major constituents of hydrocarbon. So, and the major source of hydrocarbon is crude oil. Now, this topic is very important and very interesting in the sense that if I ask you that what will you love to be in the future, some of you will say, "Oh, I want to become." Of course, everybody will want to become a doctor, and it's very good. And then from being a doctor, some will be want to be pharmacists. They want to go and study pharmacy in school. And some will tell you that they want to become petroleum engineers. They want to work with oil companies like Shell, like NNPC, like Mobile, like all these big oil companies that pay big salaries, and that's very good. Now, you need to understand that this is a foundation for those courses and the professions we're talking about. So that's why this topic is very important. So, crude oil is a major source of hydrocarbons, and let's group hydrocarbons. So, we can group hydrocarbons into two major groups. Number one, aliphatic hydrocarbons. These are usually made up of chains of hydrogen and carbon in their compounds. And then number two, we have aromatic compounds or aromatic hydrocarbons. These are made up of rings and not chain. Aliphatic is made up of chains, while aromatic is made up of rings. So, going further, we can divide aliphatic hydrocarbons into two major groups. That is acyclic compounds, that is not in cycle. That's the meaning of acyclic, not in cycle. They are not round, they are straight. So acyclic compounds. An example, we have butane. Butane is a straight chain compound. And then we have methyl butane. That one is a branched chain compound. You will see the structure in the note that I sent to you. And then still under aliphatic hydrocarbons, we have cyclic compounds. These ones are not in straight or branched chains. They are in cycle. Their open ends are joined together to form a cycle, to form a closed system. So example is cyclopropane. You will see the structure of cyclopropane in the note. And moving on, let's go to aromatic compounds. Aromatic compounds are formed from benzene ring. You will see the structure of benzene ring there in the note. Benzene ring is the basis for aromatic compounds. Now, furthermore, we can also divide hydrocarbons into other two major groups. The first two groups, we have aliphatic and aromatic compounds, but now we want to redivide them based on the kind of bonds they have. And that's where we have number one, saturated compounds, and number two, unsaturated compounds. For saturated compounds, the chain there is all single bond. All single bond. Carbon is joined to carbon and joined to carbon and joined to carbon by single bonds. There can be as many carbon carbon atom. So, but in the example I gave to you, I only showed two carbon atoms. That's ethane. So, saturated hydrocarbons, they are single bonds only. And the general name for saturated hydrocarbons is alkanes. Alkanes. And you will see the general formula in the note, and you will see example in the note. Then number two, we have unsaturated hydrocarbons. Unsaturated hydrocarbons. These ones, they have double bond or triple bond in their compound. So you will see examples there. The general name for unsaturated hydrocarbons are alkenes. Please take note of the spelling and the pronunciation. Alkenes and alkynes. Alkenes and alkynes. An example, we have ethene and ethine. So that's for the classification of hydrocarbons. Week 8 work. Now let's go to week 9, which is what we have for today. Week 9. So in week 9, we want to talk about crude oil. We want to talk about natural gas, refining of crude oil, and uses of petroleum fractions. Now, another name for crude oil is petroleum. And petroleum is the chief source of hydrocarbons. You remember that in week 8, I said that the major source of hydrocarbons is crude oil, and another name for crude oil is petroleum. So that's about that. And you should know that crude oil is a mixture of gaseous, liquid, and solid alkanes, cycloalkanes, aromatic hydrocarbons, and so on and so forth. as I was saying, we move on to refining of crude oil and uses of petroleum fractions. In the refining of crude oil, crude oil is refined by the process of fractional distillation. Fractional distillation. Please take note of that. And in fractional distillation, there are three processes that are involved. The first one is boiling. Second one is evaporation. And then the third one is condensation. So those are the three processes: boiling, evaporation, and condensation. Those are the three processes that are involved in fractional distillation. And then when you do this, that crude oil will be separated into its constituents based on the differences in their boiling points. And then what you have different fractions of the crude oil. The first one is petroleum gas. And in the table there, you will see the number of carbon atom of petroleum gas. You will see the boiling point, and then you will see the uses. And then number 2 is petrol or gasoline. Of course, we all know petrol. That's what we use to fuel our cars and generators. And then the third one, number 3, is kerosene or paraffin oil. You either say kerosene or paraffin oil. That's what we use for our lantern at home and kerosene stoves, and that's what aircraft also use for their own fuel. And then number 4, you have diesel or light gas oil. That's for trucks and engines. That's what they use as their own fuel. And then number 5, you have lubricating oil. And then number 6, you have bitumen or asphalt. Bitumen is what they use in road surfacing. If you see where they are constructing road, that black thing you see is called bitumen or asphalt. So moving on, another subtopic, we have what we call cracking of petroleum fractions. Cracking of petroleum fractions. Cracking, to put it in simpler terms, is the breaking of heavy oil, molecule of heavy oil, into smaller molecules or light oils at high temperature, high pressure, and in the presence of a catalyst. Now, the reason why we use cracking is for us to, in most cases, is to get more petrol. When I say petrol, I mean the gasoline we use in cars, to get more of it from the heavy oil like the diesel oil and the lubricating oil. So you break the heavy one into lighter one so that we can get more petrol, so that we can get more petrol. And let's go on. There are 2 methods for cracking. Number 1 is thermal cracking. In thermal cracking, you use very high temperature. You heat the heavy oil under very high temperature. Then number 2 method is called catalytic cracking. Here you use a catalyst, and the name of the catalyst is called silica alumina catalyst. You may not use very high temperature like the case of thermal cracking. So that's catalytic cracking. Now, catalytic cracking has advantage over thermal cracking. The first advantage is that the process is more controllable. You can control catalytic cracking more than you can control thermal cracking. and then it yields more petrol. And then the quality, number three now, the quality of petrol in catalytic cracking is very high than thermal cracking. So that's cracking. Away from that, let's go to reforming. Now in reforming, reforming helps us to get high grade petrol from low grade petrol. Now, low grade petrol are made up of straight chains, but when those straight chains are made into branched chains, it gives very high grade petrol. So, reforming is a process whereby straight chains, alkanes, are converted to branched chains, isomers. So that's reforming. And the process of reforming, you have isomerization and aromatization. Those are the two processes we use in reforming of hydrocarbons. So if you look at the notes, you will see the differences between cracking and reforming there. We have about four of that. So that's that about that. Now, finally, there is what we call octane number or octane rating. The octane number is a measure of the quality, or a measure of the grade of petrol. Please take note of that. High quality petrol does not destroy the engine of a car like low quality petrol. There's what we call knocking. When an engine knocks, that engine is destroyed, and it's because of low quality petrol. That's why the engine is destroyed. So to avoid that knocking, it is important to use high quality petrol. And the two compounds that are used to measure the octane number of a petrol is called heptane. Heptane is straight chain, and the octane rating for heptane is 0. And then the second compound is branched chain, 2,2,4 trimethylpentane. This one has an octane number of 100. So anything in between 0 and 100 is a mixture of heptane or branched chain 2,2,4 trimethylpentane. So that's that about that, and we round off this session and this topic and all the topics for total with what we call petrochemicals. Petrochemicals are processed products from petroleum. Examples are nylon. Yeah, you'll be wondering. The normal nylon we use is a petrochemical, is derived from petroleum. Rubbers, plastics, all these plastic buckets you use at home, detergents, paints, pesticides, all of them, they are derived from petroleum products, or petroleum rather. They are petrochemicals and they are derived from petroleum. So, with that, we come to the end of the class for today and for this term. Next class, we'll be doing revision and until our final exam. And I give you 20 evaluation questions for today. You are free to submit it anytime before next week, Thursday. Thank you and God bless you.